All right, so if you have any questions on homework 505, make sure you let me know. In class, I would go over them with you. You can also watch the video we had, and it shows you how I did it. So let's look at our notes for today. We are going to do graphs of proportional relationships. Homework 506, chapter 5.5, comes from the book and Big Ideas, about page 212. So, graphs of proportional relationships. This is written in words. Two quantities x and y are proportional when y equals kx, where k is a number and k cannot be zero. The number k represents the multiplicative relationship between the quantities and is called the constant of proportionality. So the graph of y equals kx is a line that has to pass through the origin. So if you graph it, it has to go through the origin, which is at 0, 0. So you have to basically have an equation that you can write as m equals kx, where k, that is the multiplicative relationship between the colonies, or constant of proportionality. In 8th grade, we'll call that the slope. But for 7th grade, we use k, and in 8th grade, it'll change. So basically, it cannot have something like this. It can not have a plus or a minus. If it has like a +3, it's actually going to go through the y-intercept at 3. So you learn more about that in 8th grade, but let's go for this. So let's turn the page. Guess we're not turning the page yet. There's a little thing right here. The equation y equals kx can also be written as y over x equals k. So k is equal to the value of the ratio y over x. So right here, tell whether x and y are proportional. Explain your reasoning. So we're going to plot the points. 1, -2. So we go over 1, down 2, and we put a dot. 2, 0 is right there. So the x tells you how far to the right. The y tells you how far up or down. So 3, 2, we go over to 3 and up to 2. And 4, 4 goes right there. So if we look at this line right here that we have, does it hit the origin right here? No. So that means they are not proportional. So with the graph, it has to hit the origin. You could have also checked it right here, like 1 over -2, that's -1/2. This one, 2 over 0, can't do. 3 over 2, that's 1.5. And then this is 1. So those aren't proportional. So there's a few ways to check it. So we're just talking about how to check it with a graph right now. Okay, so this one right here, we grab 0, 0. Then 2, 2, so we go over 2, up 2. And then 4, 4, so over 4, up 4. And then 6, 6. So this one, if we look at the line, it is going to hit through the origin. So since it did hit 0, 0, your answer is going to be yes. It does have proportional relationship. So turn your page now. And we're going to go ahead and graph this one. So 0, -2, 1, 1, 2, 4, and 3, 7. So if we notice, it does not hit the 0, 0. It's close, but it does not hit it. So this one would be no. You can also tell if there's a 0 here in x, 0 would have to be for y for it to be a yes. All right, 1, 4, 2, 8, 3, 12, and 4, 16. Now this one's kind of hard unless, I mean, at least on the computer, when you put in two dots, it'll draw the line for you. But on this one, I kind of use a technique from 8th grade slope. So if I notice I'm going down 4 from each one, down 4, over 1, down 4, left 1, down 4, left 1, down 4, left 1, and I hit right there. Since it does hit 0, 0, that would be yes, does have proportional relationship. All right, now this one right here, -2, 4. So I go left 2, up 4, and then -1, 2, and then 0, 0. And a lot of people are like, oh yes, it does. It hits 0, 0, and I have 0, 0 here. But you always want to graph them all because watch this next point, 1, 2. If I go over 1 and up 2, it goes back up. So this one, it is not a straight line. That's like an absolute value problem. So that one would be no. That's a trick one because a lot of people see 0, 0 and they think yes. They start graphing it. It looks like it's straight. But if you graph all the points, that one is not a straight line. So that one is a no. All right. So let's look at the next page. So this graph shows the speed of a subway car. So we want to find the speed in miles per minute. So you're going to want to put the miles on top and the minutes on the bottom. Now you can use any one you want here, but since we want the minutes to be, let's see, here's the minutes. We want the minutes to be 1. I would use this one right here. Because if we look at the distance in miles, that's going to be 1/2. So 1/2 of a mile over 1 minute. So on that one, the speed is 1/2 miles per minute. If you use one of the other ones, you could then do the unit rate and you would still get 1/2 miles over 1 minute or 0.5 miles per minute. Okay. On the graph of the proportional relationship, at the point 1, comma k indicates the unit rate, k:1, and the constant of proportionality k. This is the value. This value is the measure of the steepness or slope of a line. So we'll use a slope a lot in 8th grade. So right here, tell whether the graph of x and y are proportional. It hits right there at 0, 0, straight line. So yes, this is proportional. Now we can answer some questions based off of that. So at 0, 0, it is traveling 0 inches in 0 seconds. For this point right here, the 1 represents seconds. So you're traveling 1 second, so it goes over here. And the 1.5, that is your inches. So that actually goes right here. So you got to be careful with the labels. So this 3, that's seconds, so it goes there. And the 4.5, that is inches, so it goes right there. So double check the label on the graph when you're putting those in. Then we have one more question. It says identify the unit rate. Now remember the unit rate, we're looking per second, so 1 second is right here. We go up. That is at 1.5 inches per second. So that is my unit rate. So if we turn the page, this graph shows the area Y in square feet. So here's the square feet. And that a robotic vacuum cleans in X minutes. So here's the time. Find the area cleaned in 10 minutes. So what I like to do is use the unit rate right here, 1 and 16. So I know it cleans 16 square feet in every minute. So since I put minutes on bottom, I can put 10 minutes on the bottom and then put a variable up here. So when I do my cross products, 1 times x is x, and 16 times 10 is 160. So that means in 10 minutes, it can clean 160 square feet. So it'd be nice to have one of those vacuums if that was your job. Make it easier for you. Okay, and the last one. The table shows the temperature Y in degrees Fahrenheit, X hours after midnight. Describe a proportional relationship between time and temperature shown by the table. So if we look at this, we have to find basically the time, how much does it increase per hour? So I kind of look here, after 1 hour, it's at 46 degrees, and it started at 42 degrees. So if I do 46 minus 42, that tells me it goes up 4 degrees per hour. So this answer right here would be 4. So you basically find, where it started at 0 is a 42. So after 1 hour, it'd be 46. Now they want the temperature after 3.5 hours. So if we look at this, let's figure out how many degrees it's going to go up after 3.5 hours. So if I go 3.5 times 4 degrees each hour, that tells me it's going to go up 14 degrees. So you got to look at, where did it start? It started at 42 degrees. So you're going to take 42 degrees plus 14 degree increase, and that's going to take the temperature to 56 degrees Fahrenheit. So after 3.5 hours after midnight, it would be 56 degrees Fahrenheit. All right, go ahead and get started on your homework. Remember, if you have questions, you can watch the video of me working it out, come up and ask me questions. All right, have a good day.